Today's video, I'll talk about vicinal coupling versus complex splitting. So let's take this as an example. We want to find the HNMR signal of this middle carbon, which is a CH, okay? So how will we decide the splitting pattern? Well, if we were just talking about vicinal, we would say n+1. Now this is one type of proton because these two are equivalent, but this is a second type of adjacent proton. It's non-equivalent. So then you would use this formula for adjacent equivalent protons and multiply it by other adjacent non-equivalent protons. So we have 4 protons numbered A, so this will be 4 plus 1 times B. B is a CH2, so that will be 2 plus 1. This will be 5 times 3, so you would expect a signal with 15 peaks. Okay, so that's how that works. Now let's try more complex examples involving alkenes. Alkenes and chiral molecules, you gotta be especially aware, because we have the case of diastereotopic protons. So diastereotopic protons are non-equivalent to each other. So the fact that they're non-equivalent is because this is cis to H and this is cis to Br. So even though they're both CH2 on an alkene, they're non-equivalent. So what ends up happening is we label this as type A, type B, proton type C, and there's no proton down here. So if we want to find the coupling for HA, we'll say it is the proton type 1 times adjacent proton type 2, because it's adjacent to 2 different protons. Now let's say this is B and this is proton C, and this is called geminal coupling because we're getting splitting patterns from hydrogens on the same carbon, which only happens for diastereotopic hydrogens. And this one is vicinal, which is coupling with the hydrogen on the adjacent carbon. So then we have 1 plus 1, also 1 plus 1. So this is going to give us 2 times 2. It will give us 4 peaks in total. Another way to say this is this will be a doublet of doublet. Okay. Let's do an even more complex example involving chiral centers. Chiral centers will also have diastereotopic protons. So first is, if you see a complicated molecule, you identify, are there chiral centers? If there are, you know that any spot where there is a CH2, and it has to be a CH2, if it's a CH3 or if it's a CH, it's not going to be diastereotopic. So we can identify a chiral center here. So that must mean everywhere where we have a CH2, such as here and here, these are going to be non-equivalent protons. Okay, this is CH3, that's not going to be diastereotopic. This is CH, not diastereotopic. Okay, so that means this is type A, type B, type C, type D. Okay, so if we want to find the coupling pattern for HA, we would say adjacent proton plus 1, and this ends up being the geminal proton, the proton on the same carbon. Whereas if there weren't any chiral centers, if this were not diastereotopic protons, then we wouldn't even consider geminal coupling, okay? Geminal coupling is only for diastereotopic protons, which happens in alkenes, especially when the 2 hydrogens are on the same side of the alkene, okay? And for chiral molecules. So this is the only case when you would use geminal coupling. And then we look at some vicinal coupling. So there is one H here, There's one H here, and this is going to be type, let's see, D. This is type D proton, and we'll name this E, so then it's adjacent to many protons. So we'll call this can be B, this can be D, and this can be E plus 1. Okay, so then geminal, this will give us 2, vicinal, 2, 2. So another way to say this is hydrogen A will be the doublet of doublet of doublet. Now let's try the bottom ones here. You can pause this video and try to figure this out. So let's try to find the coupling for D. So for HD, this will be a doublet of quartet, okay? Because C, there's 1 C hydrogen, so that's 1 plus 1, that makes 2. There's 1 adjacent E hydrogen, 2, and the methyl here has 3, so 3 plus 1, that will give you 4. So this is doublet of quartet. That will be the splitting pattern for HD. So I hope this video cleared up any confusion you may have had regarding when to use vicinal, geminal, complex, or just regular splitting patterns. Biggest takeaways here: use geminal coupling when you have diastereotopic protons, such as protons on the same side of alkene, or if you have a chiral center in the molecule, all of the CH2s will be diastereotopic. And also, I need to make a very, very important note about aldehydes. So let's say you have this, and something like this, and you're being asked what is the coupling for this hydrogen. Now it looks like there aren't any hydrogens on the adjacent carbon, but this is an illusion, okay? This is an illusion because technically you don't have to draw this H, and you would actually have to consider the hydrogens on this side. So there's one hydrogen on this side, so this would actually be a doublet, not a singlet, okay? Likewise, if you're looking at this hydrogen, you want to know the splitting, you think this has no adjacent hydrogens, but that's also an illusion. There is an adjacent hydrogen here, okay? So that's a big note about aldehydes. Be aware of aldehydes, diastereotopic protons. And also, I hope in this first problem it clarified that even though it's adjacent to 2 equivalent protons, you would not split them up as another n plus 1. You would include it into a plus 1, okay? Because these two are equivalent and that one isn't equivalent.